Hi, dear students, we are studying calculus. In the last class, we saw some of the graphs. We will continue to see the graphs 2 or 3 more. So, today we are going to see a graph for the expression, or let me draw the graph first. I say we will have a graph like this. At times in physics, we are going to have a graph like this. Let us say that this is y axis and this is x axis. In that case, the mathematical algebraic equation, or say algebraic equation that is going to govern this graph will be y proportional to x square. This will be the graph. And we may at times have the graph like this also. Let me say this is y axis, this is x axis for me, and the graph will be like this. And for this, the mathematical equation will be like this. Y is proportional to x square. Or at times we may have a graph like this. If this is y axis, this is x axis, we can have a graph like this, which is mathematically or algebraically governed by like this. Otherwise, we may have a graph at times like this. If this is y axis, this is x axis, we will have the graph like this. Algebraically, this will be governed as y proportional to x proportional to minus of y square. Now, if you look at the graph, see in this algebraic equation there is a minus sign. This minus sign tells you that this parabola will have its opening towards the negative side. The sign, by looking at the sign, we can see that the opening is towards the negative side of y axis. Here we have positive sign, and by looking at this expression, we are going to see that the opening of the parabola is going to be in the positive direction of y axis. Similarly, if you look at here, we have negative sign. This negative sign implies that the opening of the parabola is towards the negative side of the x axis. Conversely, we see that here positive and opening of the parabola is towards the positive x axis. Next thing, we are going to see that x is independent variable. The degree is 2 whenever we are going to have the algebraic equation with independent variable of degree 2, the plot is going to be parabolic in nature. The plot is going to be parabolic in nature. We already saw some of the straight lines. We also saw some of the curved lines. Today we have seen the parabola. In addition to this, I have shown you the algebraic expression that governs this parabolic in nature. In addition to this, we at times come across some more graphs which I would like to show you now. So, the next graph that we are going to have will be like this. Let me say this is the positive direction of y axis. Let me say this is the positive direction of x axis, and let us suppose that the curve I am going to get is like this, and this is the positive direction of y axis. If we see the algebraic equation that will govern this graph will be y is equal to some constant e power, say minus 1 constant into x. Constant can be of any value. So, when the independent variable x is 0, the value is a. So, at this point the value is a, and I see that as the value of x is increasing, e to power minus. So, as the value of x is increasing, I will see that the value of y decreases progressively, and the value of y will become 0 only when x becomes very, very large. So, I would like to say that as x becomes larger and larger, y becomes 0. So, this is another graph. The next graph that we can have is like this. Say this is positive y and this is positive x axis, and I will see that my graph is growing and it approaches like this, and the algebraic equation that will govern this graph will be y is equal to a into 1 minus e power minus kx. So, this is the way how the graph will govern. We look at the graph here. If I expand this expression, I am going to get a minus kx. Now, this is nothing but this graph. So, you see that when the value of x is 0, then this turns out to be 1. So, y happens to be a. So, when x is equal to 0, so this is a. So, a minus a is 0. So, this is at the origin when x is equal to 0. As the value of x is increasing, we see in this graph the value of y decreases. Otherwise, this value as a whole is decreasing and y is increasing gradually. And we see that the value of y approaches the value of a when x becomes very, very larger. So, from this graph we see that as x becomes larger and larger, the value of y is approaching a constant a. Dear students, I have drawn a graph on the board, and the graph is a straight line. The algebraic equation that governs this graph is y is equal to 2x. If you put the value of x as 2, we are getting y 4. If I put the value of x as 4, 4 into 2 is 8, 6 into 2 is 12. Similarly, 8, x is 8, y is 16, and x is 10, we are getting y is equal to 20. So, this graph is governed by this algebraic expression. Now, what I want to do is I want to calculate the slope of this graph. We already saw how to calculate the slope. So, I want to calculate the slope of the straight line between this point and this point. So, for me, this will be x1 and this point will be x2, and this point I will have y1 and the corresponding value, this will be y2 for me. So, we sought to calculate the slope, we had the formula, otherwise I would say that to calculate the slope, I said on the line we required 2 points. So, therefore, I say this is 1 point, this is 1 point, or let me name the 2 points as, let me say this is A, this is B. So, A is 1 point, B is 1 point on the graph. When I want to calculate the slope, I see that the point A has the coordinate x1 comma y1, and B has the coordinate x2 comma y2. Now, to calculate the slope, we said the change in the value of y, that is rise over run. So, the rise is final value minus initial value upon the run was final value minus initial value. So, this is the formula to calculate the slope of the straight line. In my case, case 1, I wanted to calculate the slope by considering these 2 points A and B, the 2 points I have taken at the extreme ends. In that case, for me the slope works out to be y2 for me is 20 and y1 is 0. So, I write 20 minus 0 upon x2 for me it is 10 minus 0, which is nothing but I am getting 2. So, I would say that the slope of the line between point A and B is 2. Next, what I want to calculate the slope between this point and this point. Say this is C, this is D. So, this will be my second case. In that case, this is x2 for me now, this will be x1 for me now, and this will be y1 and this will be y2. So, therefore, case 2 I look at the slope when I try to calculate. So, rise over run. So, for me rise is 16 minus 4. So, it is 16 minus 4 upon run is 8 minus 2, 8 minus 2, and this is 12 upon 6, again I am getting 2. So, this time I try to calculate the slope of the straight line by considering 2 points, but this time the 2 points were closer than case 1. Let me consider now these 2 points, say E and F. So, this is my case 3. I have brought the 2 points closer. So, in case 3 for me, when I try to calculate the slope, rise over run. So, rise for me is 12 minus 8 upon run is 6 minus 4, and the case works out to be 4 by 2, which is again 2. So, by working out these cases, one thing I can make out, or the concept is that when I have a straight line graph, if I try to find the slope of the straight line, irrespective of the interval you take on the x axis and corresponding value on y axis, you are going to get the slope always same. So, this is the concept. So, what the concept says, slope of a straight line is always same in all intervals of independent variable. For me, independent variable is x. First, I had the interval from here to here. In the second case, I had my interval from here to here. In the third case, I had my interval here. So, I say that in all intervals, the slope of a straight line is same. So, thus the concept is slope of a straight line is same irrespective of the interval of the independent variables that you take. Let me see the other situation. Dear students, I have taken another example on the same graph. I have a second straight line, and this line is governed by expression y is equal to 4x. So, in this case, when I have the value of x 0, y is 0. When I have the value of x as 2, y becomes 8. So, y becomes 8, and when the value of x is 4, y becomes 16. So, this is how this straight line graph is. So, to me, let me put this is line 1 for me, let me say this is line 2, this is line 2. Now, what I want to calculate the slope of line 2. So, when I want to calculate the slope of line 2, so let me see, let me consider the separate case here. So, let me say case 1 case 1, I want to calculate slope, but what is the interval? I want to calculate between point A and say this is point E for me. So, I want to calculate between A and E. So, x2 will be this value for me, x1, corresponding this will be y2 and y1. So, thus slope is equal to rise over run. So, y2 y1, so 16 minus 0 over 4 minus 0. So, this is 16 over 4, the slope I get 4. Case 2 I want to consider here, and I want to see the slope of the line 2 in the interval 0 to 2. So, in that case x2 is 2 for me, x1 is 0, and y2 is 8 for me and y1 is 0. So, thus let me name the point. I named this one as E, let me say this is F. So, I want to calculate the slope between A and F. In that case this will be F is 2 for me, rise over run. So, therefore, 8 minus 0, 8 minus 0, 2 minus 0, which is again equal to 4. I want to calculate slope for third case. For third case, I want to calculate the slope between E and F. So, when E and F I say this is y2 for me, this is y1. So, it is 16 minus 8 over 4 minus 2. So, this is 4 minus 2, which is 8 over 2 is again 4. As we had the concept that slope of a straight line is always same in any of the intervals of independent variable, here also I see that I have a straight line and the slope is same for all intervals. But what is the difference I notice? That you see here the slope is 2 and here you see the slope is 4. So, that means slope here is comparatively more than line 1 for me. So, if I look at the graph, this is line 1, this is line 2. So, by looking at the graph and looking at the slope that we calculated, I say slope of this graph is more than the slope of this graph. So, generally if a graph is given to me like this, say this is given as 1, this is line 2, say this is line 1, this is line 2 and this is y axis, this is x axis. If I am asked which line has got more slope, then by looking at the graph I can say that line 2 has more slope. We must keep in mind this concept. That is, see with respect to x axis, see let me say this is theta 1 and this line makes theta 2. So, with respect to the positive direction of x axis, the line that has larger value of theta is said to have larger slope. Be mindful once again, the concept says that, the concept says the line that has larger value of theta from positive direction of x axis is said to have more slope, is said to have more slope. Therefore, as soon as question is asked to me which line has got more slope, what I will be looking at? I will be looking at with the positive direction of x axis, which of the line is making larger angle. Larger the angle, more will be the slope. So, dear students, I have a different situation for you now. See, let us look at the first graph. Here on this graph, I have one straight line here, followed by another second straight line, followed by a third straight line. Now, by looking at this, if the question is asked which of the line has more slope, because I have 3 lines. So, now we saw that line which has larger angle with respect to positive direction of x axis will be having more slope. So, therefore, this is the line 1, this is line 2 and the above one is line 3. I see this makes this much angle, this makes this much angle and line 1 makes this angle. So, by looking at the graph, it is evident that the straight line 3 has more slope than 2, 2 is more slope than straight line 1. That means, now here we see that the slope is changed from along this segment line 1, the slope is constant, but when I see along this line the slope is more, however, the slope is constant along this complete straight line, and when I take this one again along this straight line the slope is same, however, comparatively the slope is more than line 2 and 1. If I see here on the second graph, this time I have more number of segments. So, I hope now you can clearly tell that the line 5 has the largest slope in comparison to slope of line 4, 3, 2 and 1, and the line 1 will have the least slope in comparison to the slopes of the other line segments on this graph. If you look at the third graph, sir, when we compare this graph and this graph, this is also a curve, but made out of line segments. But if you see this one, this is a smooth curve. This is a smooth curve. In mathematics, when we have two lines like this, the point that joins the two lines is said to be kink. So, here we have one kink and here we have two kinks. Here we have 1, 2, 3, 4. However, in a smooth curve, we will never have any kinks. So, if I ask you a question that this is made up of 5 line segments, straight lines. So, if I ask you how many straight lines of which this smooth curve is made up of, then the answer is it has infinite number of line segments. If I ask you what will be the length of the line segment, you will say, sir, length we cannot say. What does it mean? It means that the length is as small as possible. We cannot describe the length. So, this is a smooth curve. Okay. In that case, you said here, so the slope is more, here the slope is less, and for calculating slope, you had 2 points on a straight line like this. Now, I want to calculate the slope of this curve. To calculate the slope of the curve, sir, at every point, if I ask you what is the slope here, what is the slope here, what is the slope here, sir, at every point the slope is changing. So, definitely another concept that we have is when I have a smooth curve, then slope is changing. The slope is changing at every point. The slope is changing at every point. That means, now there is a contradictory statement. At every point, point means one point. How can we calculate the slope at one point? It is not possible, because previously we calculated the slope by considering 2 points. So, here now I say that slope is changing at every point. That means, at this point the slope is different, at this point the slope is different, at every point. No 2 consecutive points on a smooth curve will have the same slope. Then question comes, how can we calculate the slope? This is the problem for which we are trying to build the fundamentals. So, our aim is actually to calculate the slope of the curve. Let me try to calculate the slope. Dear students, Now, I have a graph. If you look at, this is x axis, this is y axis. I hope you can see a smooth curve, this curve. What is my aim? My aim is to calculate the slope on the curve at point A. Be mindful. I want to calculate the slope of the curve at point A. Now, we saw to calculate the slope, the expression that we used was y2 minus y1 upon x2 minus x1. This we say at times, this is the change in the value of y upon change in the value of x. Symbolically in mathematics we write like this, change in the value of y over change in the value of x. Now, to calculate the slope here at point A, in mathematics we require 2 points for y and 2 points for x. However, I have only 1 point, so it is not possible. Therefore, what I did, I considered one more point here at point B on the curve. Beforehand, let me tell you that at one point, if I draw a straight line, if that straight line touches one point on the curve, you call it as a tangent. At the same time, if you consider 2 points on a curve and if you draw a straight line joining the 2 points, you call this as chord. So, tangent and chord. So, what I did, I considered one point B on the curve and tried to calculate the slope. So, joining point A and B forms one straight line, I called it as line 1. And the slope of the line 1, when I compare with the slope of the tangent, I see, I hope you will say that, sir, slope of line 1 is greater than slope of the tangent because the angle made by the tangent with the positive direction of x axis is less than the chord 1. So, I said okay. So, what I need to do, I will consider one more point B dash on the curve. So, this is second point. So, joining the point A and B dash, I have a second line. When I try to calculate the slope, so in comparison to the slope of 1 last time I calculated, the slope of line 2 is closer to the slope of the tangent, but not exactly equal. However, the delta x for the first case that I considered was this much. In the second case, when I brought the point closer to point A, the delta x is now smaller. I said okay, I want more accurate value. I considered another point on the smooth curve. I said B double dash. So, gradually I am bringing the point B closer and closer. When I consider these 2 points, then this is the span or change in the value of x, and the straight line that I got after joining A and B double dash is line 3. So, this time the slope of line 3 is closer to line 4. So, one thing that I could get the insight from the graph is that as gradually I am bringing the point B closer and closer to A, I see that the slope of the straight line of the chord becomes closer and closer to the slope of this tangent. So, question is, when the slope of the chord will be exactly equal to the slope of the tangent. The formula that we use to calculate slope is slope of a chord. We will have 2 points, but our aim was to calculate the slope at point A. When I say slope at point A, then you have only one point. So, therefore, y2 minus y1, no 2 points. So, the slope, when you try to calculate, you are going to get 0 by 0 because there is no change in value, you consider only 1 point. So, this is a problem in physics, we cannot divide 0 by 0. In order to do that, what we did, in order to calculate the slope, we considered another point. So, gradually when we take the point closer and closer, I see that the slope of the chord is becoming very closer to the value of the slope of the tangent at point A. So, thus I say that the slope of tangent, will be approximately equal to the slope of the chord, When it will be equal to slope of the chord? When the change in the value of x, what you called it as delta x, when delta x is small. Then question comes, how small the delta x must be? Sir, delta x you make it as small as possible. So, the more smaller you make the value of delta x, the slope of the chord will be more closer to the slope of the tangent, and mathematically we have to write this information. So, therefore, we would say that to make the delta x as small as possible, so we say the slope is equal to limit, we write like this in mathematics, limit, otherwise LIM straight away we write in short. So, limit delta x tends to 0, means limit delta x tends to 0, it means the value of delta x very small, but it is not 0, it is approaching 0. That means I am bringing b closer to a, delta x goes on decreasing. So, I will reduce the value of delta x as small as possible, but I will never make the point b exactly on a, because when I bring the point b and place it on a, then my problem is 0 by 0. I do not have any method to evaluate this one. So, in order to avoid this problem, what I do is I am bringing b closer to a such a way that I am trying to make delta x as small as possible. So, I would write then this as delta y by delta x. However, this mathematically we write the symbol in a condensed form saying dx by dy upon dx, like this we write. Dear students, in the next class, the concept that we have developed today for calculating the slope on a smooth curve at any point, we have given the symbol dy by dx. We shall explore more what is the meaning and how we evaluate, how we do calculations mathematics using this concept in the next class. Till then, thank you very much.